Hello everyone, it's time for another kit build, but that also means it's also time for another beer. I've got here this time a triple Carmelite, which is a wonderful Belgian beer. It's actually one of my favorites. It isn't super special, it's really common here in Belgium, and it's a strong blonde beer. How many? 8.4%, so it's already quite okay. Yeah, I really love it. You can find it quite easy here in Belgium. No, I don't know if you can find it abroad as well. Not sure. I guess in the neighboring countries at least. But yeah, let's pour it. I also have the appropriate glass as usual. Let me find my bottle opener here. Totally not prepared for this again. Let's see. Now, the Carmelite is a tricky one to pour because it is notoriously foamy, so you really have to be super careful when pouring it. If you're not used to pouring these types of beers, you will screw up for certain. See if you can also already see it coming. So you have to be really careful with this one. Wow, that's quite okay. That's a perfect pour. I just bumped into the camera. Yeah, I don't know if it's visible on camera, but let me just focus here a bit. Is this focusing? Yeah, now it's focusing. See, it's... yeah, from the top you can only see foam, but okay. Let's taste it. Wonderful. Really good. Yeah. So this means that there will be some burps probably from time to time in this video. Let's see. What have we got here? So this is a cheap kit build that I again bought on AliExpress, and it's a frequency counter this time. I paid, I don't remember, I think somewhere between 7 and 8 euros for it. So let's see what you have in terms of this amount of money, including shipping from AliExpress these days. Okay, I haven't opened it up yet, so we're gonna discover this together. So we have a display and an IC. Okay, that's a PIC 16F628A. So that's a microcontroller, which is a programmed microcontroller, and it's let's say shipped not super ESD safe. It's just yeah, just a piece of regular foam. We have a USB lead. Okay. We have all the components here, right? And then we have the PCB. Oh, it's a yellow one. That's nice. And the dreaded acrylic case. Now, I've heard from a lot of people, I haven't tried it yet myself actually, doing a kit with an acrylic case, but I've heard that it's notoriously difficult to get these things peeled off. We will see. Now let's check the manual. Okay. That doesn't look like too much. We just have here a diagram of the PCB, list of the components. Okay. The welding installation considerations follow these steps. 1. The components are welding the front board from low to high principles, namely the first low welding components such as crystals, capacitor, resistor, diode, round hole row of seats, etc. 2. The welding microcontroller header, then welding tryout button, a power outlet. Sorry. 3. The back with the diagonal cutting pliers to cut short the pins as far as possible. Yeah, okay. Let's not bother about that part for the moment. Let's just stick with this. Because I guess what I want to say is start with the components that are of a low profile. Is this tight in this bag? Okay. Now, that's a perfectly fine PCB. Oh yeah, well, what is also nice about this frequency counter, it also has a crystal tester. So that's convenient to have laying around, even if the frequency counter itself is not super useful. The parts of the case, I'm gonna put those aside. They don't even mention anything about the case. This is another piece. Let's see what we got here in terms of components. Okay. Some resistors, which have fallen out of their tape. Some other ones, some diodes, the USB socket. Okay. A button, some screws. I think these will be for the case. A couple of transistors, some headers. Okay, and some capacitors. Right, let's start. Let's start with the resistors, right? Okay, so we should have resistors 100K, 10K, and 1K. All right. What is this? This is 1001. So that's so 1, then 2 zeros, and then another 0. So that's 1K. Wait, why do we have... Yeah, that's right. Here, R6 to R13, so that's 1K. These guys, they are brown, black, black, red. So that's a 1, a 0, a 0, and then another 2 zeros. So that's 10K. And we should have 3 of those, that's correct. I think I'm already missing something here because we also should have a 100K. Ah, there is one loose in here. Is that the 100K? That's a 1, so brown, black, black, orange. So that's 1003. So that's 100, and then 3 another zeros. So indeed, that's 100K. All right, let's start with those. So maybe we'll put in that one already. That's R1. Where is my bendy tool? I have somewhere. Ah, right. Let's drink a bit. And also, the nice thing about Carmelite, what I like a lot about Carmelite is the texture. And it's difficult to explain without you having tried it. But it has a very fine texture. I find it has a lot of CO2 in there, but very fine. It's a bit champagne-like, and it's very burpy. So that promises for the rest of the video. Let's see, what do we need here? I think should be about there, right? So that's the 100K for R1. That's over here. And I think, yeah, it's a bit too wide. Okay. Let's take this one. I'm gonna clip the leads first a bit shorter because these long leads, it's just not so fun to solder. What did I do now? Okay. R1 over here. It's still a bit too wide. Do I need to take these guys here? The resistor doesn't even fit in there. Okay. Yeah, the holes for the resistors are a bit too close to each other for comfort, which is annoying. See, I don't know if you can see this, but see, they are a bit too close to each other. So you really need to bend the leads just real close to the resistor to have things neat. Where are my tweezers? This is not going really smoothly at the moment. We haven't even done a single resistor. So I guess this video will again not attract a lot of viewers, just like my Christmas special video. R1, come on, third attempt. Okay, that's better. Where is my solder? Right. Should I be using the PCB holder? Maybe. Okay, let's just tap in one side. Are we gonna use the PCB holder? Let's use the PCB holder. Let's just see me fight again against this PCB holder. Okay, that's good. Does it turn? Yes, it turns. Is it flush in there? Right. Now I probably need to refocus. Let's... I think that's focused, right? I really should have prepared this video better again. Okay, let's do these three guys. So that is 10K, that's R2, R3 and R5. Okay. Where are these located? I see R3 over there. I cannot find R2 and R5. So this is R3, R5 is over there, okay. Let's put them in the same orientation as the other ones. R5 over here. Okay. And where is R2? You're probably screaming at the screen here now, but seriously? 1, 4, 3, 5. Where the heck is R2? Oh, there. Oh, on the... all the way at the side. God damn it. Yeah. Oh. Okay. Let's solder these in. It's the first time that I'm soldering a yellow PCB. It does a bit reflective in the sense that it's very bright to look at, but that's also maybe due to my lighting here on the bench, which is pointing directly straight down and probably reflecting off of the PCB, but still, it looks nice, but it's, I think a green one or a black one is easier to solder. Let's first check if we have, yeah, see, I wanted to say, let's first check if the resistors here are nicely in there, and they aren't, before we, see, this one is a bit crooked, before we clip off the leads. That's better. Okay. It's starting to rain here, actually. That's maybe what you're hearing? Yeah. Now the other ones, they are all 10K, so that shouldn't be an issue. So that's R4, and then R6 to R13. Right, they're just falling out. Okay. Yeah, that's just R6 to R13, so that's all these 7 here, or what is it, 8 here in the back. And so this is this 10K? No, 1K, 1K, 1001, yeah. Okay. And okay. Where is the other one? Oh, there, R4, right, okay. So this is just a bit of repetitive work now. And I noticed that they are all delivered here precision resistors, or I don't know if they are precision resistors, they are metal film. So that's nice. And I'm just trying to put all of these in the same orientation. Obviously that's not required, but it looks nice. Yeah, like this. And I have no clue how this will work, or if it will work decently. We will see. Yeah, and my PCB holder was in the way there. Okay. R12. Come on. The holes here are really slightly too close together to make it comfortable, but hey, I'm not complaining. For €7. Right, and just one more, and that's this guy over here, R4. Okay, now I know that not everyone likes to do it like this, but yeah, I just to twist the leads here of the resistors to hold them in place. It's not the best way to do it, but it's easy and fast. So now I am quite pleased with the channel at the moment. I am above 1,700 subscribers, which is just amazing. I mean, I never thought when I started the channel that one day I would have 1700 subscribers. I remember checking when I just had the channel out of curiosity what the requirements were for monetization of the channel, and I saw that they said like 1000 subscribers and I believe 2000 hours of watching time. And I was like, okay, forget about it. That will never work, or that'll never happen. I'll just upload some videos that I like, and I hope that maybe someone someday can make use of the videos and to repair, maybe if he's repairing the same device or something. But then, the channel grew, and we passed 1000 subscribers about a year ago now. And it has been steadily growing since, so that's really, really nice. I never expected that to happen. So thanks to you guys, thanks to everyone who is subscribed, and we'll just continue doing what we do. Still have a couple very interesting projects coming up. There are a couple pins here which do not really have a lot of solder. That one, for example. But I think that's fine. Okay. So I don't know, I don't think these types of videos are very popular. If you look at my Christmas special, then you see that it doesn't have a lot of views. But honestly, I don't mind, because this type of video doesn't take a lot of effort for me to make, because there is almost no video editing involved in this one, or in this type, because it's just shot in one go. And so it doesn't really take a lot of effort to put something out like this. And I notice that some people do enjoy it, so why not? Okay, the resistors are done. Let me just pause, stop and start the video here quickly. Okay, so I do this because sometimes if the app on my phone, because I'm recording this with my phone, it crashes and then I lose the video that I was recording. So just to limit the chance that I lose the entire video here. Okay, so now what is next? Maybe the capacitors. Yeah. Ceramic capacitors. Oh, there are a bunch. And a lot of different ones. Let's see what we got here in terms of ceramic capacitors. So this is 104. That's a 100 nano, I guess. Yes, this is a 102. That's a 100 pico. 1 nanofarad. Yeah. The 22. That's a 22 pico. Another 22, I think. Yep. Another 22. Another 104 and another 22. Okay. So the first thing they say here is the two 100 nanofarads, C1 and C7. C1 and C7. Let's see that, yeah. Oh, that's on over there. And there is something in the middle in between, that's a voltage regulator. Okay, let's do the capacitors first. C1 and C7, yeah. Okay, I'm just going to put this slightly high, because I don't like it when these types of capacitors, when you put them in all the way, that they are really with that, because if you look at these types of capacitors, the ceramic, it goes a bit on top of the legs. And if you put it in all the way, then it just looks like it's sitting with its feet in the mud, which I don't really like. So I usually put these like a millimeter above the board. Not that it matters a lot, but it looks better. And okay. Now, I don't know what voltage that this PCB requires, but maybe we can try running it off a lithium cell or something like that. I also don't know how much power it takes. This one is maybe sitting a bit too high, but yeah, it doesn't matter. Next one is the 102. So that's the... Man, this beer is so good. The 1 nanofarad, that's C6. C6, where is C6? There. That's a very tiny one. In general, I don't like these tiny ceramic capacitors. They are just a bit too fiddly. See, they are so small. Okay, and then we have 4 22 picofarads, and that's C2, C3, C4, and C5. Okay. C2. What is a pity is that they don't give us a schematic. That would have been nice, because then we could look maybe a bit at how it's working. Not that you would see a lot, because it's a microprocessor controlled thing. C2, C3, where is C4 and C5? There is C5. I cannot see C4. This is C5. You probably have already seen it already. There it is. Jesus. We have this expression in Dutch that says, if it was a dog, it would have already bitten you. It's to say, like, if you're looking for something that is really close by, but you cannot see it. And honestly, I really like doing these types of projects, or kits. If you enjoy watching this type of video, then just let me know, because it's always nice to get a bit of feedback, to see what am I doing wrong, what am I doing good, what do you like about the video, what not. Because if nobody likes this, then yeah, I'm not gonna continue posting these types of videos, right? Okay. This is, for me, this is a bit like slow TV. See, they have these video streams from, for example, trains driving through the landscape. I think in Norway this is quite popular. And for me, this is the same type of content. Honestly, I like watching this myself, or I put up a video like this while I'm doing the dishes or something like that. It's a bit zen, and it's also a chance for me to talk a bit to you guys about just about anything, about beer, for example. And again, I asked it in the last video also, if you have any questions or any topics that you want me to address, let me know. Then we have something to talk about. I don't have a good internet connection here in the on the workbench or in the workshop. So if I had, I would have done this on a live stream. But yeah, it's not an option. Okay, let's get a move on here. The diodes, maybe. Yeah. So we have 5 regular small signal diodes, so 1 and 4148. It is gonna work with my scissors as well. Oh, they are a bit thick, but it works. Yeah. These I am going to fold with the tool here. And yeah, there are only 5 diodes on this thing and they are all the same. So it's just D1 to D5. And they do mention here a black in the negative. So yeah. Yeah, it's a bit jingly, these instructions, but okay. Honestly, I don't think we need a lot of instructions. We only need the parts list here is the most important thing. So let's see. Yeah, that fits. That was the correct size to bend. Yeah, there was something else that I wanted to say. I recently enabled a membership feature on my channel. Now, the main reason why I enabled it is because I don't want to flood your feeds with, yeah, let's say behind the scenes content, because every time when I pick up a new radio or a new piece of test equipment or something like that, I really have the urge to take a picture of it and put it on the feed, but I don't want to do that because I need to restrain myself a bit in posting all these pictures and showing you what I'm doing in between projects or what is coming up. I'm definitely not going to do that because I don't want to spoil anything. But if you would like to see those things, then you can always now sign up to the membership here on YouTube. You won't get any extras in terms of videos. I don't want to do that. All my videos will always be 100% free and available for everyone. There will also be no early access for members or these kind of things. So it's just behind the scenes content. If I pick up a new radio somewhere, you'll get a picture of it. If I'm working on something, you might get pictures or posts of how projects are coming along. But you won't get any special videos or anything. It's just a way for me to post things without flooding the the timeline of regular subscribers. So that's also why I kept the membership fee quite low. I think I set it at €2 per month or something. I wanted to give some away for free, but apparently that's not possible. You can only give away memberships in a live stream or in a premiere. And since I don't do these kind of things, I cannot give any memberships away. So that's a pity. Otherwise, I would just have given a couple of memberships away to people that would like to have one. But unfortunately, that's not an option. Okay, so what will we do next? I think I have the diodes here incorrectly. Yeah. The crystal, that's also rather low profile. Should also be on the list here. Oh yeah, crystal, 20 meg. Yeah, it's a 20 meg crystal indeed. And it is located right over there. This is going to be annoying to put it in because it has really short legs. Oh, it holds itself in quite well. Nice. Okay. Let's quickly solder it in. Yep, and it dropped out. Right. Let's chip those pins off a bit closer. A bit shorter here. Okay. Next, the transistors perhaps. Oh wait, there we have 2 transistors and a voltage regulator. Let's see. This is an S8050. That's an NPN transistor. Oh, that was a burp. Sorry. Another NS8050. Feel another burp is coming up. Yep. Apologies. This is labeled 7550. So -1. That's the voltage regulator, and it has to go in U1. U1. And I guess this means we do have a schematic drawing. Yeah, okay. It's really tiny though, but okay. I guess they mean... It's a very weird way to draw this type of package, but... And the leads are also a bit further apart than the actual leads over here. Where are my pliers? Over there. I'm just going to bend them ever so slightly. Just to do things according to the books. Right. This is really not necessary. You can just plug it in and it'll work as well. But yeah, why not be fancy if you can be fancy, right? Okay. And I do have the voltage regulator here, yes. And let's plug it in like that. Okay. And with these two guys, I think we need to do the same, because they have the same sort of footprint here on the PCB. And come on. Always when you want to go the extra mile, it's always screwing things up. Right. Radio. In my the pub where I usually go, they have this from Tap, the Carmelite, and it's amazing. It's totally different from Tap compared to from the bottle. But it's both nice. Like, I mean, I really like it also from the bottle, but from Tap it's something else. Because if you know a beer from Tap, typically the CO2 is added at the tap, so you don't have the oh, this is not great. You don't have the fermentation in the bottle, or only partially. You have a lighter amount of fermentation compared to, well, how should I put it? In a beer, normally you have the fermentation process, and then you put the beer in the bottle, but then you add a tiny piece of sugar still to the bottle so that it can ferment again. You have a second fermentation in the bottle. When you have a beer from Tap, you cannot do this because, yeah, I don't know the real technical reasons, but in any case, you can't really do the second fermentation on a barrel. So you need to add CO2 from a CO2 canister while pouring. So that means that depending on how much CO2 you add, it can be different between different pubs. And so same with this, because this beer, the CO2 in there is very characteristic for this beer. So it will be totally different from Tap. Usually it's much more soft. It's much more velvety if you drink it from Tap than from the bottle. This one. But anyhow, I really like it. Now let's hope that here, this orientation, that I am assuming the correct things here, because the flat side of the footprint, that it's also the flat side of the transistor. If it wouldn't be the case, then they would be real bastards to draw it like that. And that one just fell out. Yeah, let's solder these two in. Let's just solder one pin to hold them in place. Where is this one? Over here. U3. Okay. Let's fold over one of the legs. Come on. Okay. I wonder if I again do these types of videos that it will be just me talking about soldering and beers. Hey. Okay. Maybe I should also, next time, put up some music in the background, some royalty-free music playing in the background, just for a bit more atmosphere and a bit less silence when I'm concentrating. Alrighty then. That's actually looking quite good. We are getting there. Next, right. The socket is maybe not a bad idea. Oh, yeah. Gonna do the socket next. If I don't have any components already in the way. It's one of these cheap ass sockets that they used. Oh, it's totally bent. Yeah. So they didn't really have been very careful when putting this socket in this foam. This totally non-ESD compliant foam. I think that's better. Yeah, that fits. Right, let's solder one leg just to keep it from falling out. Come on. Okay, that's enough. Yeah. And now let's do the other pins. Normally I like sockets with round contacts. They make better contact than these guys, but okay. For a project like this, I can understand that they go for a cheap socket. I guess they just, when they make these kits, I just guess they just take the cheapest components that they can get from every type and yeah, put them in the bag and that's it. So it's probably all shitty components and counterfeits and fakes and whatever, but yeah. We assume it'll work. Well, that one is taking a bit more heat because it has a big track over here. Okay, almost done with this socket here. Right. Okay. I remember when one of the first times that I was changing a socket was on an arcade PCB where someone must have spilled like a soda or something, or a lemonade or a cola or something over the board, and all the sockets were corroded. So I had to swap all the sockets. And I remember the first time when I was doing this, I thought like, okay, yeah, let's just hold it in place and solder it like that. Well, yeah, of course, you could really see the burn marks of the pins on my on my thumb. That was also immediately the last time that I soldered a socket like that. What else? Yeah, I think, okay, let's maybe do these headers here. That is a bit of the same issue, right? Now, what is that? Where do we need a header and where do we need the socket? I think the socket is here for the crystal tester. JP1 3-pin hole seat. Okay, I guess they mean a socket. These are also annoying to hold in place. But if it is multiple ones, like over here with 3, you can hold one in place with your finger and then solder another one, because you have the same issue and they get hot on the other side as well. And then let it cool down and then see if it is straight. No, it isn't totally straight. Let's heat this up again. I think that's better. Yeah, that's okay. Let's do the other two. And let's reflow this one again. Okay. Yeah. And now J1 is for the jumper. And now, of course, here my socket is in the way. So, okay. So that's this guy, I believe. And, oh, it doesn't fall out. So I'm just quickly going to solder the top pin here. These pins, they take quite a bit of heat. So, all right, that's in. Now the other two. I'm putting a bit too much solder here on these pins, but yeah, okay. Right. What else? What do we have left? We have the jumper for this, what we just soldered. We have the DC socket, the push button, this connector, and the display. Maybe the push button first. Switch S1, regardless of the polarity. Right. So that's this guy. Okay. It's actually looking pretty neat. I do like this yellow PCB. Did it just fall out? Yes. It dropped a bit. And you don't want that on the switch. So, yeah, well, there it is. We're gonna always reflow the first one again. Okay. That looks good. I'm burping a lot here. I warned you. You can't say I didn't warn you. Okay, the header. H2. Why is it so crooked? Huh? Well, the pins are a bit bent. Okay. That fits snugly, but it is still not totally straight. Okay, that's better. We're almost there. We're almost there. I think we only have the display left. Ah, and also the connector. Let's do the connector first. I think it goes in that way, so that's a bit annoying. Yeah. Because if I do that, then I cannot... There is no way to put it in the holder anymore. So let's do the display now. And oh, these pins. Yeah, you see that this foam, why it is not a good idea to put components in a piece of foam like that. First of all, it's not ESD safe. Second of all, you just bend all the pins. It's a mess. But anyway, right. Should go in like this. And now because the pins have been bent, it's not easy to line them up. There is one in the middle which is out of alignment. And here they are also... Oh, this is just annoying. Come on. Yeah, those are in, I think. Nope. Where are my tweezers? Which ones are holding back here? Right. Okay. I think they are all in. Right. So this is what is this, 5-digit display? I didn't pay attention. I think it's a 5-digit display. 5-digit, yeah. So this is a 5-digit 7-segment display, and every digit has actually 8 segments because the dot is also a segment. So you should have 8 pins plus 5 for the selection of the digits. So that's 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5 for the selection of the digit, and then 1 for ground, probably. Not in this order, but it's always like that with these displays. You have the total number of pins is the amount of digits you have, plus 8 for the segments, plus 1 for ground, or for positive, depending on if you have a common anode or a common cathode display. Now, I am going to do a video shortly where we're going to talk, well, shortly, I don't know how shortly, but I'm planning a video which involves displays, because I have designed a project myself, a small one, and I'm going to make a video about it, and it involves driving a display. So I'm going to explain it all much more in detail again, how these types of displays work. They are super simple, but you just need to know what you're doing, and they all work the same. Okay, I think we are done with this. Let's snip off the leads. Okay, rightio. And now we can. Yeah, no, I'm not gonna take off the plastic here yet. The plastic foil. Yeah, that's not gonna work. I don't think we still need this guy. Let me just refocus here. Okay, then the only thing left still to do is here the plug. And that's quite easy. And then I think we're done. I don't know what the jumper is about and how we need to set it, but oh, these holes are very big. It's gonna take quite a bit of solder to fill. Oh, come on. Jesus. You bet. Yeah, the problem is that for these types of solder jobs, the solder that I'm using is too thin. It just takes too much of solder. But hey. Doo-doo-doo. Yeah, I think we're done. No, I know that we are done. And it's crooked. See, it's a bit... yeah, okay. Can I fix it? Nah. Let's just leave it and not screw things up. Let's have a beer. Awesome. Right. Okay, the welding installation has been done, I think. Oh, yeah. After completion of welding on IC microcontroller, pay attention to the direction of IC insert that might damage the chip. Okay. I guess... Yeah, I hope that they put it in the right way in there and that it should be like this. Because the notch is over there, so... Normally I would use my ESD bracelet to do something like this, but yeah, I mean... Are all the pins in? Yeah. Okay. Right, the button. Can we put in the button without having the case? I think so. Not sure. Let's leave it out for the moment. Check the IC weather against such as anti-please timely correction. What? Okay. After the check, the electricity, the fourth digital tube display 0 said the installation was successful. Yeah, this is not helping. Anyway, I don't know what voltage we need. Is this just 5 volts? Yeah, it's just 5 volts. Oh, do I have a USB charger here somewhere? I think so. I think I have to find one. Do I have a USB charger here? I don't think I have, honestly. That's unfortunate. Yeah, so right. let me see here if I can find something. And I'll just quickly pause the video and see if I can find a USB charger here. Okay, so I have everything hooked up here in a way that is actually really super safe, and it will definitely not blow anything up. So the ground here on this connector, which I guess is the ground, just is connected to the shield, to the outer side, and the pin is positive, so that's here hooked up with this plug that I took. Yeah, it's perfect. And I hooked it up to the power supply of the bench, and let's just see what blows up here. Huh? Nothing, actually. It seems like it's doing something. Oh, okay. Well, let's turn it off again and see what we have here. So, using the step. Okay. Before measuring signal, please switch jumper J1 cap. Blue terminals for input signal, ground for ground signal, input signal amplitude cannot higher than 30 volts, otherwise may damage the frequency meter. Okay. Okay, so this is the frequency metering position. Wow, this jumper is really tight. That's the frequency metering position, and that's the crystal test. Okay. Jesus, this jumper is crap. Yeah. Okay. Right. Let's boot up the signal generator. And I don't have test leads. Yeah, I really came very prepared for this. Yeah, let's take some test leads. Just a sec. Maybe I'm also gonna take some small leads to put in there in that contact, if I can find some. Yeah, oh, this should do. And those leads are okay. And a test lead for my signal generator. Yeah, this is probably very interesting YouTube video at the moment. All right. Now, this is not the most convenient way to do to measure a signal, but hey, let's just see if it works. I'm just gonna hook up some small wires here, and then I can hook up my test leads onto that from the signal generator and see how accurate this thing is, and see if it works at all. Actually, that would be the first requirement. Actually see it working. Okay, now that's in. Signal generator. And what are we gonna start with? 1 kilohertz or something like that? Yeah, it's set to 1 kilohertz, 4 volt peak to peak. Okay, let's turn on the power supply. Okay, let's turn on the signal generator. That's not great. What is the button for? What does the switch do? Nothing. See, if I... It's not doing anything. Blue terminals for the in signal, yeah. Ground for ground. Signal input can be 130 volts. That's not the case. See, if I turn off the signal generator, it's doing something, but no, wait. After the check the electricity for digital tube display 0, so that's correct. Said the installation was successful. Okay. Before measuring signal, please switch J1 jumper cap to this. Yeah, that is. Blue terminals. Okay. Yeah, I don't know what else to do here. Is this making good contact? Ah, maybe it's not making contact. Is it making contact? Yeah, it should. I mean. Is my amplitude not enough? It's almost not possible. Ah, wait. The amplitude was not enough. Oh my god. Okay, so this is now 10 volt peak to peak at 100 hertz, and that's correct. Wow. Let's go 101 hertz. 101. Wow. Okay, let's go 1 kilohertz. 1 kilohertz. Now, yeah, the input voltages needs to be high enough. I now have 10 volt peak to peak, which is quite high, and which makes this not super useful in some applications. But let's see how far we can get this. I'm now at 10 kilohertz, and it's acceptable, the accuracy. Let's go to 19. I know can you see it on the screen? Yeah, I didn't check if you could see it, but it's visible, right? 20, 30. Okay, 40. Oh, yeah, that was my mistake. But it's what is this? This is very accurate. Let's do the sexy thing here and peel off the protective, if I can get it off. Yeah, this doesn't promise well for the plexiglass itself. Oh yeah. Oh yeah. Okay, let's see how far we can get. Let's go to 100 kilohertz. Perfect. 200, 300, 400, 500, 600. Okay, let's go immediately to 1 megahertz. Oh no, it's dead. Right, 900, 800. Ugh. 700. Okay, let's up the amplitude. 20 volt peak to peak here now. Wow, okay, that is 15 volt peak to peak. No, it's acting up. It's not great, but it's doing something. It's 800. Okay. 900. I dropped the voltage to 8 volt now. If I go, let's go a bit lower now again. It's yeah, see, it's weird in the sense that it depends a lot on the input voltage. 1 megahertz, 2 megahertz. No, it's out again. See, so yeah, do I have to drop the voltage again here? I'm now playing with the voltage here to get it to read the 2 megahertz, but no. Nope. This is not happening 2 megahertz. No, it's not. It's not reading it. Okay, right. So it is working. It's doing something. And as expected, it's better at lower frequencies than it is at higher frequencies. I'm now back at 80 kilohertz, and yeah, the voltage that I'm having here is now too low. Oh yeah, so here, see. So 5 volt peak to peak here now. This is 5 volt. Yeah, it's okay. Right, the crystal test. Let's see if I can find a crystal. Now, I don't know if I have any laying around here. Where are my crystals? Oh yeah, I do. See, I have some scrap crystals here. What is this? That is a bit too high, probably. 10, that's gonna be 10 megahertz, perhaps. Let's check this one. This is 18,900 kilohertz, so 18.9 megahertz. Will it work? Let's disconnect this. Let's put it in the other position. And now, how do I need to plug this in? Before measuring the crystal, please switch the jumper cut to J1. In JP1, that's over there, insert 40 meg to 4 meg to 40 meg crystals can measure the crystal frequency. Okay, but okay, pin 1 and pin 3 like this. Okay. 18. Wow. Okay, this is useful. 18.9, it's 18.9. Okay. Let me just test all my crystals here. 9.999, and indeed it's a 10 megahertz crystal. This is, wow. Okay. What else do we have here? 22.118. 22.125, okay. Do I have a higher one or a lower one? Let's see. 16,000, what is this? 16. Awesome. 4. That is right at the edge of what it can do. And it works. That's nice. But I still don't know what the switch does. What the hell? Why is there a switch? I don't even see it on the schematic here anywhere. Ah, there is a switch. That's to... That pulls one of the lines of the CPU to low. Ah! Oh, quit. What is this? Huh? No. Add sub 0 table quit. I'm gonna do quit. Yeah, I don't know what the other things do. There is a QR code here, so that's probably explained in there. Okay, now let's turn this off. Let's see how good I will be at these things. I think I need more beer for this. Everyone always says that it's very difficult to take these things, these covers off, but so far it's not that difficult. See? Okay, that's already one. And it'll take a while to get all these things off. But yeah, they are coming off. That's already one piece done. Now, what can we talk about while doing this? I think if you are still watching this at this point, kudos to you, because it's a longer video than I was expecting it to be. I think I was expecting it to be shorter than the Christmas episode, but I'm afraid it will be longer if I... okay. All right. I can start to see the point why this is annoying, but it's coming off, so we are not complaining. It's really thick acrylic or plexiglass, and yeah, you do have to fiddle indeed a bit with it to get it off. Yeah. Yeah. What else? Now, what is coming up on the channel? I would like to finish the RR radio quite soon. The things that I still need to do about it are, yeah, I just keep postponing them. What I'm gonna do is do them one by one, like one thing every week or so, and then post the footage when everything is done. It's taking too long, this project. In the meantime, we also have the Philips amplifier, which I'm starting to like more and more. I have the spare components in stock that I needed in the meantime, so I can continue on that one. This is going quite well. Famous last words, probably. Now, that doesn't mean that we have put it together, because that will also be a challenge. Now, I do like these kits. It feels a bit like Lego for adults, but with a crappy manual. Let's turn off the solder station. So you do have to figure out everything by yourself. And okay, last piece. Then we have to see how this will fit together, because there are no instructions about the case. So I hope it will be straightforward. Ow! Come on, my nails are almost gone because of doing this. So it's good that it's finished. Okay, right, so this is the top part. Let's take off these things again. Now, so this is the top part, yeah. Okay, then that's the bottom part, and then you have these things here in between. You have two short ones and two long ones, so it doesn't look to be too difficult. Now the problem is how we're gonna hold all of these things together while wait, what is this? This needs to fit in there. The case is pretty well made, actually. Let's maybe do like... Oh, we have different lengths. What the... okay, so we have screws to hold the PCB in place, and then different screws to hold the case in place. That's cool. So, need to take these out again. and then put the PCB in there. With the short screws. I don't know if I'm still in shot. I'm looking at the camera. I think I am. I hope I am. Otherwise, this will be a very boring video if you just hear me talking and don't see anything. Now the only thing that we still need to do here is just tighten these bolts, or these screws, however you want to call them. And I already screwed up. Yeah, I already screwed up. I drove this one in too far. Okay. Let's do 2 of the 4. These don't need to be too tight because otherwise you will either break the plastic or break the PCB. Is there something? Ah, yeah, see. So the pins here of this connector, they are sticking out quite a lot. So I'm not going to tighten this extremely hard. Well, you will never be able to tighten this very well. Wait, how many things do I have here? I have way more nuts than... So I guess the point is that you... Wait, I'm missing a short... Oh no. See, the Carmelite is working, I think. This is not the best thing to do when you've had a strong beer. Wait, let's start over. So I have already 2 on here, so we need 2 and things are falling out. And then we have 4 for the case. And then I have 6 left. What? How does that work? Wait, oh no, that's 5. Then, huh? I have an odd number of nuts? What is this? How? What? Huh? Do I need to use a nut probably as a spacer? That's a possibility. I guess that's the idea. So we need to start over again. So that you first do it like this, then you put the nut on there. Okay. And you do that 4 times. I'm really starting to feel the beer, actually. Let's tighten these guys a bit. Yeah, come on. And I'm assuming that I'm now doing things right because I'm still not sure. Ouch. What did I do here? Right. Now the reason why there are multiple different frequency counters on AliExpress. And the reason why I got this one is I wanted it to go quite low. Lots of those on AliExpress, they promise you higher frequencies. and I wanted to have one which went into the lower frequencies. So that's why I took this one. I wanted one that also clearly could show the audio range, because a while ago I did the restoration of an audio signal generator here on the channel, and that one wasn't really accurate anymore after all these years, and there's also no way to adjust it because, come on, you don't have the, it's not adjustable. It's these frequencies are set by means of precision resistors and capacitors. So if you want to adjust the frequency, you need to start swapping capacitors and resistors, and I'm not gonna do that. So it might be a good idea to just mount a thing like this on there, and yeah, but what is this? Why is it not fitting? Oh, you need to drop in all 4 exactly at the same time, but the holes are not lined up. Let's just use force, brute force. There we go. Now I do think that this is the idea. You do it like that, and now you put on another nut, and you start cursing, because these nuts are so small and the remaining parts of the screws here are also quite small, and it's just annoying, and they fall out. But since it goes nicely to 1 megahertz, I think it should work. Now, we have seen already that we have a bit of an issue with the amplitude, that it has to be a good amplitude in order to be able, so that it can read the signal. That's a bit annoying, so I don't know if it'll be useful. That was my multimeter. What is this for? Yeah, that's for the long edge. This is a short edge. There's another long edge, and the short edge here, this one has a cutout for the connector, the power connector, and of course now it doesn't fit in anymore because I was yeah, see, that doesn't fit anymore now, huh? What the hell? See, that doesn't fit. Okay. This will never work. Yeah, that's my multimeter. Or is it like this, perhaps? But then it needs to, it cannot go in like this, right? Let's use brute force again. And I cracked it. Son of a bitch. Yeah, since we have cracked it anyway, let's just jam it in. It's in. Nothing happened. There's nothing went wrong. Everything is fine. And indeed, it was like this. I should have put it in there first. But no worries. We will just continue. Like that, and then this one like this. All right. And then, and if I tighten it up like this, I will not be able to push the put the button in. So let's first do the button. Come on, I cannot even put the cap on the, there it is. Okay, that almost fits. So brute force isn't always the solution. See, we have a crack over there now, but... So if you're putting this together, do that side panel first, right? And then these guys, they need to go all the way through, and it's coming out again here. And let's put a nut on there quickly. Oh, come on! I'm just gonna grab my tool to tighten these nuts, but I will do that after the video. I'm not gonna bother you with it. Okay, oh yeah, it's tightening quite well. Just don't over tighten it, because you can see how easy this this plastic can break. So, right. And I have 3 nuts left. Why? Why do I have 3 nuts left? Let's tighten these slightly. Not too much, because we have already broken enough. There we have it. Done. Jesus. That took longer than expected, and yeah, the case is easy to put together if you know what to do, and I didn't know what to do, so I cracked it, but you hardly noticed that actually. Let's plug it in again and see if I didn't break anything. It's still working. That's nice. Now what I don't really like is how deep this connector is for the crystal tester, because see, these crystals here, these are salvaged crystals. Now this one will fit in. That's not going to be a problem. See, 9.8355, and it is a 9.832. But sometimes this guy over here, see, that will not... Ah, it fits through. Oh, that's great. That's nice. Okay, I like the crystal testing functionality. Honestly, it's already worth it just for the crystal test. The frequency counter is a bit less useful. I pushed the menu button again. I still have to figure out what the menu button does, but okay. Right, I'm actually happy with this. Now, the annoying thing is that it runs off of USB. So we can maybe fix that in a later video. If you are interested, maybe we can try to get this running off a lithium cell. I do have a lithium cell here. You saw it in one of my videos lately. I do have the circuit in the meantime to protect the lithium cell from over and undercharging. I do have the PCBs to boost up the voltage from the volts from the lithium cell to 5 volts. So we should be able to get this running off a lithium cell. That would be nice, because now it's a bit annoying that you cannot just take it out like you have these testers, for example. These ones, see, they have all the leads are flying off here. These ones, they have a battery inside, so it would be nice to be able to use it like that as a quick frequency counter or a quick crystal tester. That's amazing, actually. I like that. Okay, let me finish my beer. If you are still watching, then you deserve a medal, I think. And yeah, if you want it, I bought it on AliExpress. Just make sure that you shop around a bit, because these can vary quite a bit in price, and there are multiple sellers most of the time selling these things. And buy the cheapest one, because they are all the same. And yeah. yeah, that's it. I'm not going to make the video longer than it already is, because I guess it's super long at the moment. So yeah, I'd like to thank you for watching, and then I hope I'll see you in one of my regular restoration videos again. I will put one out, I guess, rather early, because these videos, they don't take a lot of time in editing. So I will see you later. Take care. Cheers. And bye-bye. Okay, so short addendum here. I managed to get it working a bit better. I'm now at 9 megahertz and 5 volt peak to peak, but I set my signal generator to 50 ohms output instead of high impedance. I'm not sure. Here I am 10. See, I can go higher now. See, my signal generator goes up to 30 maximum, so I'm maxing out now my signal generator. But the weird thing is, if you go at, let's say, let's take 7 megahertz or something, if I go up in amplitude, now my 10 volt peak to peak, okay, it still registers. See, there it's gone. Now I'm at 3 megahertz, 10 volt peak to peak, and it doesn't detect that. That's weird. If I then go down in voltage, see, not really anything. But, so now I'm 6 volt peak to peak, 5 volt peak to peak, and it doesn't, there it is, now 600K. Now let's go up, and again it's gone. So that there is something weird going on here. Yeah, here there are certain ranges or frequencies that it doesn't really detect pretty well, but outside those it's working fine. Now I did have a look at the QR code. There is a bit better explanation of how it works and what the button does, and in correct English also. Now the button enables a sort of program mode. Let me just put it here back on 30 megahertz. That's 20, this is 30. The button enables a sort of program mode, which is quite interesting. So let's see. So yeah, this is quit. If you go to the menu, this means, so I didn't know what it is, but it means no power saving, and the L I think is LED or something. If you enable the power saver mode, then after a while the display goes out if the frequency doesn't change. So that's ideal for if you're running enough batteries. Then you have here these functions, add or subtract. They allow you to set an offset. So if you are measuring an oscillator in a radio, for example, a local oscillator, you can measure in the RF stage and then add or subtract the oscillator frequency. Might be interesting. So how you do that is you apply the frequency that you want as an offset, and you press subtract or add, and then it calculates this as an offset. So the disadvantage is you cannot just enter, let's say, 450 kilohertz or something if you want that as an offset. No, you really have to apply that frequency and then have it on the display and then save it as an offset. Okay, then this is 0, so that just sets 0 offset, so it resets the offset feature basically. Then you here have table, and that is a list with pre-programmed offsets. So if you go into table, see there you have 455 kilohertz, you have 3.999 meg, you have 4.19 meg, 4.43 meg, 10.7. So see, this is the typical FM oscillator. So let's use this guy as an offset. And now we should be able to go back in the menu and then say subtract. Yeah, now I just subtracted 30 megahertz from 30 megahertz, right? Because if I go to 20 now, see, then I have the difference is 10. So now, no, that's not, but see, it's working. I had the 30 megahertz that was on there as an offset now. So let's set that to 0 again. 0. Now, how does this, yeah, now I'm at 20. Let's go back to 30. Now, how does this table functionality work? Let's go back to table. All right. The 10.7. Okay. Normally, it says that you should then, after you selected a value from the table, you should be able to select add or subtract. But it doesn't want to do that. Ah, here for 455 you can, let's say, subtract. Oh shit. Subtract. Yeah, see, now it's subtracting 455 kilohertz from my 30 megahertz that I'm putting in. But for some reason it didn't work on the 10.7. See, now I'm putting it 10 megahertz and I'm reading here 9.54. So that is, now let's zero it again. See, I'm at 10 megahertz. So that is maybe convenient in some weird applications, but okay. Interesting. Right, I just wanted to add this short addition to the video because it looks like it's a bit better than I originally discounted it for.